Good morning, one and all. Myself, Dr. Radhika, working as Assistant Professor in the Department of Agricultural Engineering, SNS College of Technology. Last class we discussed about the soil acidity and alkalinity. Today's class we discussed types of acidity. There are three kinds of acidities. One is active acidity, salt replaceable acidity, otherwise exchangeable acidity, then residual acidity or reserve acidity. Then fourth one is total acidity of soil. Finally, we discussed about the total acidity of soils. There are active acidity, salt replaceable acidity, residual acidity, and total acidity of soil. Then let's see one by active acidity. First one is active acidity. Active acidity is a measure of hydrogen ion activity in the soil at any given time. A particular time, any time, we have to assess the hydrogen ion activity in the soil solutions. So it represents the active acidity. So active acidity is defined as the measures of hydrogen ion activity in the soil solution at any given time. However, the quantity of hydrogen ions owing to active acidity is very small compared to the quantity in the exchangeable and residual acidity forms. Very small. Active acidity is very small compared to quantity in the exchangeable and residual acidity, other types of acidities. For example, only about 2 kg of calcium carbonate would be required to neutralize the active acidity in a hectare or furrow soil of an average mineral soil of at pH 4 and 20% of moisture. So, compared to an exchangeable residual acidity, active acidity only 2 kg of calcium carbonate required for neutralize the active acidity in a hectare furrow slice of average mineral soils at pH range is 4 and at moisture level is 20%. Then even though the concentration of hydrogen ion owing to active acidity extremely very small, it's important because this is the environment which plants and microbes are exposed, whereas very active acidity is very less ranges, so it exposes the plants and microbes are the these conditions. The concentration, even though the concentrations of hydrogen ion owing to active acidity is extremely small, it is important because this is the environment to which plant and microbes are exposed. These are the points are discussed in the active acidity. First of all, activity is measures in the hydrogen ion activity in the solutions at any given time, that is called as active acidity. The hydrogen ion activity is very small compared to the quantity of exchanging and residual acidity forms. So very, then for example 2 kg calcium carbonate enough for this rectifying the active acidity, even though the low range of active acidity responsible for the plant and microbes exposure. Then let's see the salt exchangeable acidity. The exchangeable or salt replaceable acidity is also due to hydrogen and aluminum ion present in the exchangeable compound. Suppose exchangeable compounds when the hydrogen ion and aluminum ions are present is called as exchangeable acidity. The ions can be replaced into solutions on unbuffered salt such as potassium chloride, otherwise called as KCl. Its moderate acid soil, the quantity of easily exchangeable aluminum and hydrogen is quite limited. In the active, compared to active acidities, the aluminum and hydrogen ions exchangeable easily is very quite limited in the salt replacement acidity. At a given pH value, exchangeable acidity is generally highest for smartite, intermediate for vermiculite and lowest for kyanite. The exchangeable acidity is very lower in the kyanite of clays mineral and the very intermediate for vermiculite type of mineral and smartite type of mineral is very highest the exchangeable acidities. Then last one residual acidity and or potential and then reserve acidity. Residual acidity is that which remains in the soil after active and exchangeable acidity has been neutralized. When the remaining of active and residual acidity, its other one is residual acidity. Residual acid is generally associated with aluminum hydroxyl ion and hydrogen aluminum atom that are bonded in non-exchangeable forms by organic matter and silicate clays. Because of organic matter and silicate clays, the hydroxyl ions bonded with hydrogen aluminum that are bond non-exchangeable form, non-exchangeable bound. So it's occur the residual acidity, potential acidity, or reserve acidity. These are the three terms we used the residual acidity, potential acidity, then reserve acidity. And then as the pH increases, bound hydrogen aluminum can released by calcium and magnesium. Suppose pH increases, bond of hydrogen and aluminum can be increased released by calcium and magnesium. The residual acidity commonly for greater than the area active and salt replacement acidity. The amount of ground limestone recommended at least partly neutralize residual acidity is commonly 4 to 8 megagrams per hectare furrow slices. Thank you, one and all. Next class, let's see sources of soil acidity in soil. Thank you.